In this video, we're going to take a look at how to solve a system of equations that has three variables. Now, we've been looking at how to solve an equation that has two variables, and we learned three techniques. We learned graphing, the substitution method, and the addition or elimination method. And for a system that has three variables, we really can't use graphing because we do not graph in 3 dimensions, which would be required because you'd have to have 3 number lines. So we use primarily substitution and then the addition or elimination method. The easiest way to start is to use the addition or elimination method, and I'm going to number the equations here so that you can kind of follow what I'm doing. So we have 3 equations, which we need to have 3 because remember, your number of equations has to equal the number of variables. So 3 variables, 3 equations. And what I want to do is combine 2 of the equations together to eliminate one of the variables. And I notice almost immediately that the first equation has a coefficient of -2 on the y, as well as the third one has a +2. So I'm going to combine together equation 1 plus equation 3. So when I do that, I have 5x minus 2y plus 3z equals 4, and 3x plus 2y minus z equals 4. Adding those together, I have 8x minus 2y plus 2y goes to 0. 3z minus 1z is 2z, which is positive, and that equals 8. So that gives us, we've created a fourth equation that only has 2 variables. From there, I have to use equation number 2 because we haven't worked with it yet. So I need equation number 2, and I'm going to add that to 3 times equation 1 because I want to eliminate the same variable, which would be the y. So if I do that, equation 2, I have -4x plus 6y minus 7z equals -1. I'm then going to multiply the first equation by 3. So I have 15x minus 6y plus 9z equals 12. I'm going to add those 2 equations together. -4 plus 15 is 11x plus 6y minus 6y is 0. Minus 7z plus 9z is plus 2z, and -1 plus 12 is 11. So again, at that point, I have a fifth equation in which I've eliminated the y variable. So I can then take equation 4 and 5 and combine them together. So I'm going to do equation 5 plus -1 times equation 4 to eliminate the z. So I would have 11x plus 2z equals 11. Multiplying equation 4 by -1, I would have -8x minus 2z equals -8. And I'm going to add those 2 together. 11x minus 8x is 3x. Plus 2z minus 2z is 0, and that equals 11 plus -8, which is 3. At that point, I have an equation that is in a single variable that I can actually solve and find the value of x. So if I solve this equation, which would be equation number 6, I'm going to divide both sides by 3. So x has a value of 1. I then have to take that value, and you basically at that point have to backtrack the equation to find the other values for z and y. So I'm going to take the x is 1 and go back to equation 5 and substitute it in. So I would have 11 times 1 to 1 plus 2z equals 11. 11 plus 2z equals 11. Subtract 11 from either side. I have 2z equals 0. Divide by 2, divide by 2. So z is 0. So I now know that x is 1 and z is 0. And I'm going to go back to equation 1 and I'm going to substitute those values for x and z into it to get the value for y. So I have 5 times 1 minus 2y plus 3 times 0 equals 4. And I've got to solve that particular equation for y. So I have 5 minus 2y plus 0 equals 4. 5 minus 2y equals 4. Subtract 5 from either side. You get negative 2y equals negative 1. I'm going to divide both sides by negative 2. So we have y equals positive 1/2. Typically, your answer here is written as a tripled ordered pair. We write it in the form x, comma y, comma z. So in this case, I would have 1, 1/2, and 0. Now, to be confident that this is the right answer, you can substitute that tripled order into all three equations and be sure that it equals the respective value of 4, negative 1, and 4. Makes a true statement. If it doesn't, then we've got a calculation error somewhere. All right, let's look at one more. This one I have 2x plus 3y minus 6z equals 1. That's going to be equation number 1. Then I have negative 4x minus 6y plus 12z minus 2. That's equation 2. And then I have x plus 2y plus 5z. That's going to be equation 3. Now, it doesn't really matter which variable we eliminate. In this one, it looks like it's going to be reasonably easy to eliminate the x. So I'm going to do that. I'm going to take equation 2, and I'm going to subtract 2 times equation 1. So I have negative 4x minus 6y plus 12z equals negative 2 minus, or add to it, not subtract, excuse me, I'm going to add. Okay, 2 times 2x is 4x. 2 times 3y is 6y. And 2 times 6 is negative 12z. And that equals 2. Okay. Ooh, this looks interesting. Negative 4x plus 4x is 0. Negative 6 plus 6 is 0. 12 minus 12 is 0. So I end up with 0 equals 0, which is a true statement, but there's no variable, which seems to imply that this statement's going to be, those two together at least would have any equation or any ordered pair that makes it true. Let's double check and see what happens when we do equation 2 plus 4 times equation 3. So I have negative 4x minus 6y plus 12z equals negative 2. And then I would have 4x minus 8y plus 20z equals 40. And I get negative 14y plus 22z equals 38. Okay, that one didn't work out quite like we thought. And because the first two equations are the same equation and you have three variables, basically what this means is you can't solve this problem because you can't eliminate one of the variables. And basically, because this equation is the same as the second one, you really only have two equations and three variables. So this particular problem has no solution.